Hello, everyone. It's Mr. Chappa, and you may notice that I'm actually in our classroom. I did go to campus as soon as my car was ready because that's where I should have been at this time, and it's a good place for me to record this video. All right, so this is Format 1342, Section 001 for Monday, November 7th, 2022. I have 4 goals in this video. Number 1, review the z-distribution table that we talked about last Wednesday. Number 2, practice using the z-distribution table, which we did quite a bit last Wednesday. And speaking of last Wednesday, I am aware that the notes have not yet been scanned and uploaded. I'm going to try to get that taken care of as soon as possible. Number 3, introduce the t-distribution table. And number 4, practice the t-distribution table. Now, the homework for this is already in Canvas on the homework assignments page. Let me show you where it is. Let's see here. To go here, that's not it. It is, one second. Homework pages, homework home, homework page, homework assignments. If you scroll down to where chapter 5 would normally start, I'm doing Z and T distributions, which is my substitute for chapter 5. This link takes you to the homework assignment, which I've already got opened here. It is a total of it's a total of 15 different normal distribution questions where you either have to find Z's or T's at cutoff areas or find let me rephrase that, where you either find areas that are cut off by certain Z's or T's, or certain Z's or T's that cut off certain areas. Like this one says, find the Z-score that cuts off a left tail area, a left tail whose area is 2.5%. So that's there. And then the quiz is already here also. And the quiz is open and it is due on the 7th, I believe. Doesn't that say that somewhere? I don't see a due date here. One second. And it's not due the 7th, it's due the 9th. Huh, well, now it says it's due the 9th. Okay. All right, so the quiz is available and it is due on the 9th. And does it not say it here anywhere? What if I go back to quizzes? Quizzes, Z&T distribution quiz, yes, due November 9th. All right, so that's there. All right, let's go back to the whiteboard, please. All right, the quiz is already available and is due by 11:59 p.m. on Wednesday, November 9th, 2022. All right. So let's start by reviewing the z-distribution table. Everything that I'm about to show you, for the most part, is something we've talked about already. Recall that a standard normal distribution, that's a key phrase to know, so let's highlight that. Recall that a standard normal distribution is a bell-shaped distribution with a mean of 0 and standard deviation of 1. Also recall that the z-score for a value of x in any distribution is the number of standard deviations x is above or below the mean. There's a formula for it. We've seen it before. It's either x minus mu over sigma at the population level or x minus x bar over s at the sample level. Now, we won't actually be using this formula in this video, but later when we get into chapter 6, we'll be using formulas that are based on this. The standard normal distribution table, z-chart or t-chart, is the table that gives the area under a standard normal distribution to the left of a given z-score. And it actually says this in the z-distribution table. And if I can get it to share, this is the same distribution table that I handed out in class last Wednesday. If you don't have it, if you go to the home page or go into modules, there should be a module. Let's collapse them. Thought it was here. Was there an announcement with it? I know I linked it somewhere. There's the thing saying I'm not here today. Here it is. Handouts from 11 to 22. So if you click on this, the Z distribution, the T distribution, and the test 3 formulas, I gave out all of these last Wednesday. But our Z distribution says at the top, cumulative area under a standard normal distribution curve, under a standard normal distribution curve to the left of a given Z-score. All right, so let's practice. For example, find the area to the left of Z equals negative 1.07. I meant for the stuff below here to be covered up. So just so it doesn't distract us right now, let's cover it up real quick. Okay, we'll come back to it in a minute. All right. If we want to find the area to the left of z equals negative 1.07, then that means in our curve, which has 0 in the middle, and I'm using a mouse to draw this because I couldn't find a stylus, z equals negative 1.07 would be over here to the left of 0. And I'm going to make this line width a little bit wider. And we're looking for this area over here. Well, since we're finding a left area under a standard normal distribution table, that is precisely what this chart tells us. All we have to do, sorry, my phone dinged. Okay, all we have to do is find negative 1.07 in the z-chart on the edges, on the left edge and on the top, and then see the corresponding z-score. To find a z-score, you first find the first two digits, negative 1.0 here, and then you, for the second decimal digit, you find the correct column. It was negative 1.07, so we need to see where this third from the last column intersects that given row, and it looks like it intersects right here at 0.1423. So that means that our desired z-score is 0, let's get the text box ready. Answer, the area, excuse me, we have the z-score, is 0.1423. I believe that's what it was. Let's see. 1 second, folks. Sorry, this is what happens when I'm recording a video and students text me. I don't want to keep them waiting. Yes. Because it was about something that's going on right now. All right. Was it 1423? I think it was. Let's go back to the chart and see if that's what I highlighted. Yeah, 0.1423. But we could also look at this as a percent. We could also look at this as a percent, or 14.23%. All right, so it's a pretty easy chart to use. And we can also use it to find right areas, even though our chart tells us left areas. To find the right area, to find the area to the right of a given z-score, you have one of two options. Number one, look up the area to the left of the z-score and subtract from 1, subtract from 1, or look up the area to the left of the opposite z-score. This works because of symmetry. For example, let's say we wanted to find the area to the right of z equals 0.83. If we draw our bell curve and get used to drawing them, they're going to be all up in the next chapter, all up on the next test, and find 0.83 over here. It'd be to the right because that's greater than 0. And we're looking for the area to the right. Now, when you are looking up these areas, it would be a good idea to think ahead of time. Should my answer be more than 50% or less than 50%? Since I shaded in less than half of the bell curve, it should be less than 50%. But we're looking for the area to the right. So we can do one of two things. Number one is look up the left area, left of 0.83. If we unhighlight this for a second, if we look to the left of 0.83, well, let's go to 0.83. 0.8 is here, and the 3 is here, and the intersection is 0.7967. But 0.7967 is the left area. So we could say the left area equals 0. And I forgot what it was, 7967. 7967. So let's fix that. The right area is 1 minus that 0.7967, and that equals, let's see, 0.2033. And that's what the right area would be. Or we could do something different. Or we could say the area right of z equals negative 0.83 is the same as the area left of, I can type, z equals negative 0.83. Let's get rid of that line break. So instead of looking up 0.83, we would look up its negative, and the area we want should be there. And let's see. If we go to negative 0.83, let's get rid of this highlighting. If we go to negative 0.83, negative 0.8, did I look in the correct column? I did. Negative 0.83. Now, if you can't see the top to see which column is which, you can just count from the left. Just remember to start counting with 0. Negative 0.8, 0, 1, 2, 3. And looky there. The area that we calculated is exactly in there. So you have two options for how to do right areas. Either look up the left area and subtract from 1, or look up the area to the left of the opposite z-score. But whichever one you decide to do, stick with it. Don't go back and forth between the two because it gets a little bit messy. All right, to find the area between two z-scores, warning, this is something I haven't shown you yet. So hopefully if you're watching this, you're like, wait, what was that? To find the area between two z-scores, look up both of their left areas and subtract the results. For example, let's find the area between z equals negative 0.93 and z equals negative 0.15. If we draw the bell curve, it looks something like this. Not the most horizontal line. Here's 0 in the middle. Negative 0.15 would be to the left of it. But negative 0.93 would be further to the left of that. So if we wanted to find this area, think about what would happen if we looked up both z-scores. If we looked up the z-score on the right, it would tell us the area right here. And if we looked up the z-score on the left, let's use a different color. If we looked up the z-score on the left, it would tell us this area. Well, if we take the yellow area and subtract the pink area, it will tell us this area in the middle. So all that means is look up both z-scores areas and then subtract them. Starting with, it doesn't really matter which one, just always do the greater area minus the lesser area. Area to the left of z equals negative 0.15 is, I like putting is there instead of back-to-back equals. Let's find negative 0.15. Negative 0.15. Negative 0.15. Negative 0.1, let's just count to the right. Remember, first number is 0. Negative 0.1, 0, 1, 2, 3, 4, 5. Not the best highlighting job, but it's that one with a lot of 4s in it. And again, it's not that hard to just scroll to the top or look to the top to go, yeah, that's the correct digit. So 0.4404. 0.4404. 0.4404. That would be the yellow tail. The area to the left of z equals negative 0.93 is, let's go back to the z chart, 0.93, 0.93, 0.93, 0.91, excuse me, start counting with 0. Negative 0.9, 0, 1, 2, 3. Looks like it's 1762. 1762. Which is the pink tail. So the area between these two z-scores is 0.4404 minus 0.1792, which is whatever it is. Got a calculator handy somewhere. Well, it's here. Whether or not it's handy is debatable. Where'd you go, calculator? I know you're here. I saw you. I know I could probably do it by hand faster, but I'm a little bit stubborn like that. Okay, well, maybe I didn't bring a calculator. Whatever. I should need a calculator anyway. I don't need a calculator. 4404 minus 1792, 0.2612. Or 26.12%, if you will. So to find the area between two z-scores, look up both of their areas and subtract the results. To find the z-score that cuts off a given left area, find the area in the middle of the z-chart. For example, find the z-score that cuts off a left area of 85%. Now, when you're doing these problems backwards, meaning that you start with the area and you find the z, stay focused. I want to find a z-score that cuts off a left area of 85%. Well, that's over half of it. So my z-score needs to be over here somewhere. If I know that this area that I'm shading in, that I'm about to shade in, if I know that this area, why is this not drawing? There we go. If I know that this area, again, please forgive the crude shading. I'm using a mouse, not a pointer. This area is 85% or 0.85 or 0.8500. Then what's the z-score? Well, to work it backwards, we have to find 0.8500 inside of the z-chart. There's a good chance it's not in there exactly. See if we can find it. Get rid of all that. All right, now the areas in here are in here in some sort of order. The best advice I can give is to start looking in the first column and keep going until you find something reasonably close to what you're looking for. I'm looking for 8500. I am nowhere near that. Let's keep going. We're getting there. All right, somewhere in this neck of the woods, and more specifically, somewhere between these two rows. So just scanning to the left. All right, it's not in here. It's not in there because 0.8500 is between these two numbers in my z-chart, which are associated with 1.03 and 1.04. So what do we do now? Well, if you're looking for a z-score, if you're looking for an area and it's not there, then it will be between two areas. 85% is between these two numbers. So which z-score do we use? And the answer is whichever z-score has the closer area to the desired area. Between these two numbers, and I want to zoom in really large, which one is closer to 85%? Well, you can just use the subtraction problem to figure out. And if you ignore the decimals, we're really trying to ask the question, which is closest to 8,500. And let me take the font size down. I know I'm zoomed in ridiculously, but that's okay. So which is closest to 8,500? And the way to do that, if you ignore the decimal, is to do two subtraction problems. If I subtract 8,508 minus 8,500, the difference is 0.0008. And if I do the same thing on the other side, the difference is 0.0015. And again, the decimals are there, but it really doesn't matter because we can just ignore the decimals in all of them. But the one that's closest to the area that I'm looking for is this one. It has the smaller difference. And so I'm going to use that z-score. You don't actually have to do a subtraction problem. You just have to look at it and see which one is closer. But if you can't tell, then you can do a subtraction problem. We want 1.0, too much highlight there. We want 1.0, and let's go see what's at the top, 4. So 1.04 is the z-score that we would use. I'm going to kind of write what I just said. The desired area, 0.8500. Let's move this down a little bit, is between 0.8485 and 0.8505. I believe those were the numbers. Let me go check real quick. 0.8, okay. In the z-chart. Since 0.8500 is closer to 0.8508, we use the z-score for 0.8508, which is z equals 1.04. It's actually not that difficult to do. Just find the area closest to the one that we're looking at. So the rule to follow is this. If the area you are looking up is not in the z-chart, choose the closest area and then use its z-score. Does raise a question. To illustrate it, let's take a look at this example. Find the z-scores that cut off a middle area of 90%. And believe it or not, this situation will occur more often than you think. All right, middle area, remember how that works. If the middle area is 90%, then that means that the remaining 10% is split amongst the two tails. Now, these z-scores will be opposites of each other since the bell curve is centered at 0, so we really only have to find one of them, and keep in mind, our z-chart likes left areas, so we're going to find the left z. In order to find the left z, we need to think of this area as a 4-digit decimal. 5% as a decimal is 0.05, but as a 4-digit decimal, 0.0500. So that's what that left area is. And now we just have to go in the z-chart and figure out what z cuts off a left area of exactly 5%. Let's erase all this. Let's see if I can get rid of this. Saying hit the trash can. All right, we are looking for 5%, and let's go back to the top till we can find it. All right, scanning down the first column, I'm looking for 0500, or if you were to ignore the decimal place, I'm looking for 500. Let's find it. 500. 3, 5, 7, 10, 13, 19, 26. Got to keep going. 500, 500, 500. All right, I found the neck of the woods where it would live. It's somewhere around here. So let's just go to the left and let's find it. Let's see. On the front page, the areas are decreasing from left to right. And so if we start on the negative 1.6 row and go across, here's 505, there's 495. 500 lives between these two. But which one is 500 closest to? And again, I'm ignoring the decimals. Which one is 500 closest to? 505 or 495? And the answer is it's a tie. It's a tie because both of these are 0005 away from 0500. Again, ignoring the decimals. Let's highlight the numbers. Both of these are the same distance from 500. So which one do we use? Because our rule is choose the one that's closest, but they're the same distance. Well, I've seen all kinds of, here's what you do in this situation, but this is what we are going to do. The rule is going to be this. If the area you are looking for is exactly between two areas in the z-chart, use the z-score with the larger second decimal place. In other words, when this dead center scenario happens, I am always going to default to the rightmost number because the rightmost number will have the greater digit on the top. I have a reason for defaulting to the larger digit on the top. It has to do with significance levels and confidence levels. But for now, that is the procedure that I want you to use. If the area you are looking for is exactly between two areas in the z-chart, use the z-score with the larger second decimal place. So to answer this question, 0.0500 is exactly between 0.0505, whose z-score is negative 1.65. Let's see. Negative 1.64, excuse me. Whose z-score is negative 1.64, and 0.0495, whose z-score is negative 1.65. use the score with the larger last digit. Hence, we use z equals negative 1.65. All right, it takes a little getting used to, but basically you're choosing the one that's further away from the center. For reasons which we'll see later, it's better to default further away from the middle than closer to the middle. All right, and I see I misspelled exactly. I know that doesn't matter, but it does to me. All right, now let's introduce the t-distribution. The t-distribution is another normal distribution. In other words, it's a bell curve. However, it's not a standard normal distribution. Although its mean is still 0, the standard deviation varies depending on a quantity called degrees of freedom. And I just introduced a new vocabulary term, degrees of freedom. And the variable for degrees of freedom is df, so it's a two-letter variable. We'll talk about what degrees of freedom means when the time is right. But there are three key differences in the z-chart and the t-chart. Number one, the t-chart uses the area to the right of a t-score, not left. Number two, the t-chart can only accommodate 6 different right tail areas. I'll show you what they are in a minute. And number three, the t-chart is set up like the z-chart, except inside out. What do I mean by that? Well, in the t-chart, the areas are on the top of the chart instead of in the middle, and the t-scores are in the middle of the chart instead of on the edges. When we use the t-chart, we use it mostly to find t-scores that cut off certain areas. We can't use the t-chart to find a specific area for a given t-score, but we can find a range of areas. Translations. Z-charts are made for problems like this and like this, but not for problems like this or this. All right, we're going to practice using the t-chart by finding a t-score that cuts off a right area of 10% if the degrees of freedom is 12. Let's take a look at the t-chart. You'll notice the t-chart says it's for right tail area, so that's good. Here are the 6 areas that I told you about. The t-chart can only accommodate these 6 areas as percents: 10%, 5%, 2.5%, 1%, 0.5%, and 0.1%. On the left column are your degrees of freedom, and all of the numbers in the middle are your t-scores. So to look up a t-score in the middle, we need to know the correct row, which is based on degrees of freedom, and the correct column, which is based on the right area. So this is actually pretty easy. If the right area is 10% and the degrees of freedom is 12, then we simply go to the 10% column, which is the first one, and we go to 12 degrees of freedom, which gives us the row. Those intersect right here, and the t-score is 1.3562. Again, the t-score is kind of like the t-chart is kind of like the z-chart, except inside out. So is there a picture? Of course there's a picture. There's always a picture. Bell curve, still 0 in the middle. We're looking at a 10% in the right area. Area equals 10%. And degrees of freedom is equal to 12. So this means go to the df equals 12 row and the 0.10 column. Find t equals, what was it? It was 1.3562. 1.3562. 1.3562. Piece of cake. But Mr. Chappell, what if it's a right area? Oh wait, this is a right area. Never mind. Thinking something else. Find the t-score that cuts off a right area of 2.5% if the degrees of freedom is 58. Okay, 0 in the middle. Right area is 2.5%. Come on, text box, thank you. Area equals 2.5%. Degrees of freedom equals 58. So we just have to go to the correct column and the correct row. The correct column will be the third one, 2.5%. The correct row will be whichever one says 58 degrees of freedom. And this is a 2-page table, which means we may have to flip to the next page. There it is. Here's 58 degrees of freedom. I believe we were in the third column. And so they intersect at 2.0017. T equals 2.0017. So it's a really easy chart to use. You just got to get acclimated to it. And if you give me 1 second, I'm going to draw a line that separates these two examples. I'm doing that because all of the things that I'm writing here will be saved as a PDF available in Canvas. To find the t-score that cuts off a left area, just find the t-score that cuts off the right area and change its sign. Again, this is based on symmetry. Find the t-score that cuts off a left tail whose area is 5% if the degrees of freedom is 35. Left tail, 5%. Area equals 5. And we have degrees of freedom is 35. There's not a visual for the degrees of freedom. It's just a measurement. And we want to find what this t equals. Well, 5% and 35 degrees of freedom. 5% and 35 degrees of freedom. Let's clean this up. 35 degrees of freedom will be on the front. 5% will be the second column. And 35 degrees of freedom. Second column, 35 degrees of freedom, 1.6896. But it was a left tail. So it's negative 1.6896. Excuse me. Sorry, folks, it's been a long day. T equals negative 1 point, and I already forgot it, thanks to that yawn. Yeah, that's the reason why. Negative 1.6896. Negative 1.6896. And again, this is because t equals 1.6896 cuts off a right tail of 5%. So we just take advantage of the symmetry. All right, last thing about the t-chart. Well, actually, let's do a middle area problem. And yes, we will be doing middle area problems quite a bit. We got 99% in the middle, which means one tail, well, the two tails are 1%, so one tail is half of that, so 0.5%, which as a decimal is 0.005, and somehow my font got red. There we go. All right, 29 degrees of freedom, 0.5% in the left tail. 29 degrees of freedom, 0.5% in the left tail. Let's find the right column. 0.5%. 0.5% is the second to last column. Degrees of freedom was 39, I believe. Come on. Okay, not sure what's going on with my Zoom session here. 1 second. All right, it's better. 29 degrees of freedom, 0.5% in the tail. 29 degrees of freedom, 0.5% in the tail. Second to last column, 29 degrees of freedom, 2.7564. But the left tail is not cut off by 2.7564. The left tail is cut off by negative 2.7564. And of course, the right tail would be the opposite of that because of symmetry. So t equals 2.7564. All right, a couple of issues with the t-chart. Number one, it can only accommodate so many degrees of freedom. In fact, the last one is 75. After that, you'll see what's literally an infinity row. It's the craziest counting ever. 71, 72, 73, 74, 75, infinity. Can we have more rows between 75 and infinity? Of course. Do we want to? No. We're just going to go with this. This is pretty standard. So if the degrees of freedom are too high, just jump to the infinity row. For example, find the t-score that cuts off a middle area of 95% if degrees of freedom is 99. Well, if we draw the picture, trust me, I'm going to ask you to draw lots of bell curves on your next test. Middle area is 95%. That means there's 5% left over, and if you cut that in half, the area of one tail is 2.5%, and we're at 99 degrees of freedom. 2.5% is the third column. 99 degrees of freedom is too large, so it takes us to the infinity row, and we use 1.9600. 1.9600, except the left one would be negative. Oops. Negative 1.9600. It's the right one that would be positive. Remember, the T-chart has right areas. All right, so just the last row in case the degrees of freedom is too large. All right, so here's the weird part about the T-chart. We can't use the T-chart to find an area cut off by a specific T-score. Unlike the Z-chart, where we did several areas, what's cut off by is here's the Z-score, find the area. It's going to be difficult to say, here's the T-score, find the area, because think about how the T-chart is set up. The T-chart has T's inside the chart. For example, even if we knew the correct row, like if we were at 10 degrees of freedom, what does T equals 2.5 cut off? Well, if you go to the 10 degrees of freedom, 2.5 is not even in here. So what do we do? Because if we go to the correct row and have a T-score in mind, there's a good chance you're not going to see it in that row. Well, there is a protocol for this. We can't use the T-chart to find the area cut off by a specific T-score. However, we can use the T-chart to find a range for the area cut off by a T-score. And here's how we do it. First, we locate the correct row based on the degrees of freedom. Then we find the two Z-scores that the desired Z-score is between, because what you're looking for probably isn't there, but good chances between two of the numbers that are in there. The area cut off by the desired T-score is between the areas cut off by those two T-scores. For example, find the range for the area cut off by T equals 1.25 if degrees of freedom equals 19. If I draw this picture, here's 0, here's T equals 1.25. I should have said the right area. And that is so sloppy down there, I'm just going to go retype it. After all, I can type, sort of. 0, and then over here we have T equals 1.25. And the question is, what is this area? Well, if we go to the correct row, which is 19 based on the degrees of freedom, we're not going to find 1.25. 19 degrees of freedom. 19 degrees of freedom is this row. And 2.5 isn't in there. Now, you might think, well, let's use the one that's closest. Well, no, because it's going to be really inaccurate to say the area is this when it's nowhere near that. But here's what we can do. Find the two numbers that 2.5 is between. That would be these two numbers. 2.5 is between these two Z-scores. Then go to the top, and you'll see two areas, 2.5% and 1%, if you will. Since my T-score is between these two T-scores, the area is between these two areas. So we would say something like this. The area is between 0.01 and 0.025. Or if you wanted to do it in terms of percents, between 1% and 2.5%. So that's the best that we can do with the T-chart if we have a T and we want to find an area. This is going to be something we do because we're going to be finding p-values, which is areas cut off by tails. Those tails may be cut off by T-scores. So we can't say the area is definitely this, but we can say it's between these two numbers. With technology, we can get a good estimate for the area instead of just saying it's between these two. Now, if the given score is not between two t-scores in the appropriate row, then the range of areas is either greater than 10% or less than 0.1%, depending on which side of the t-chart, the given t-score would fall. For example, let's say we want to find the range of areas cut off. I should say range of area, it's singular, cut off by t equals 3.5. Let's go over here to t equals 3.5. If the degrees of freedom is 44. Well, let's go to the 44th row and look for t equals 3.5. 44th row, and we want t equals 3.5. 44th row, it's right here, t equals 3.5. It's not between any of these. So where is it? Well, now you have to imagine what would happen if we had more columns. T equals 3.5 would be past this. It would go off over here somewhere. So what does that mean about the area? Well, the areas on the top are getting smaller as we move from left to right. And the rightmost column's area is 0.001. If we went further to the right of that, we would get an even smaller area. So since our t-score we're looking for is off the chart on the right, we would say that the area is less than 0.001 or less than 0.1%. And again, that's because the t-score we were looking for, 3.5, in the correct row is off the chart to the right. It's off the chart to the left. Well, find a range of areas cut off by t equals 1.5 if degrees of freedom equals 3. Let's draw the picture. (1.5), 3 degrees of freedom. And the question is, what's this area? Question is, what's this area? Well, let's go to the third row, 3 degrees of freedom. Let's look for t equals 1.5. Third row, so way up here. Let's look for t equals 1.5. Let's go across the row. Oh, wait a minute. These numbers are all greater than 1.5. 1.5 isn't between any of these. But seeing that the numbers are increasing from left to right, where would 1.5 fit in this row? The answer is it would fit to the left of 1.6377. So that means its area would be over here somewhere to the left of 0.10. But again, the areas on the top are decreasing from left to right. So from right to left, they're increasing. So since the area I'm looking for is to the left of 0.10, that means the area I'm looking for is greater than 10%. Area is greater than 10%. Well, 0.10 or 10%. And I don't really need this here. There we go. So why does that matter? Well, if this represented a p-value, it'd be more than 10%. Because we don't know what it is, but we know it's more than 10%, so it's definitely more than 5%. So we would not reject the null hypothesis. All right, these problems are really easy to do. You just got to get acclimated to using the z and the t distributions. Your homework questions are just like problems illustrated in this video and like was demonstrated in class last Wednesday. This quiz is due Wednesday night by 11:59 p.m. So if you have any questions, you should come to class prepared to ask them. And if you don't have any questions, then you should take the quiz, do the homework and take the quiz.